Hi everyone, welcome to this channel, GCP for Dummies. This series is based on the Associate Cloud Engineering exam provided by Google Cloud. We're going to go step by step in this prep for this exam. If you like this video, hit the thumbs up and subscribe, and I wish you the very best of luck in your exam. Following the last couple of videos, we were introduced to core concepts of cloud services. In these next few videos, we're going to introduce ourselves and focus to Google Cloud Services. We've got 8 core types of Google Cloud Services, and I've added billing because that too is covered in the exam. So our core services are computing resources, storage resources, databases, networking services, IAM, which stands for Identity and Access Management. We've got development tools, management tools, specialized services. Let's first look at compute resources. These shouldn't be new to you, we've covered a little bit of them in the previous videos. The screenshot here shows you what you will see when you log into the Google Cloud Console. As you can see, all the compute resources lie under the compute section on the Google Cloud Console navigation bar. We've got IaaS virtual machines, which are available on the compute engine, under compute engine. These give you the greatest control because you can configure them a lot more than you can with PaaS or with Kubernetes. Moving on, we've got our PaaS, which are serverless computing, which are available under compute resources as well. There they are, App Engine and Cloud Functions. These require less configurations, which makes them ideal for situations where you are confident with the tasks that you have and you want to repeat them at specific times. Then we've got Kubernetes clusters, which are also available here under Kubernetes Engine. These two require less configurations. To better understand how virtual machines work, I've included this diagram which shows the infrastructure of how VMs sit on Google servers. You may see this diagram in probably less colorful colors around on Google Cloud certification webpage, but here it is. We've got the server on Google's data center right at the bottom, and this is where everything that you will pay for or rent from Google will sit. On that, we'll have our operating system. This is again specific to what you need the solution to do. On top of that, we've got what we call a hypervisor. This is a visualization layer so that we can use guest operating systems. As you can see here, the white section here, square, where you can see the folders, that's our guest operating system. And then on that, you can upload your virtual machines to run your applications. So a quick recap of what we need to create VMs. We need a name, a machine type, a boot disk, and a region or zone. You have the possibility of adding GPUs and more CPUs if you see fit. If you notice on the top left, I've got a light bulb, which means that this is information that you should already know, or you might know it, but you don't need it for the exam specifically, but it's good to know. The little new sign shows you that this is content we haven't covered before, and this is something you should pay attention to. So here, we've got the factors to consider when we're choosing a regional zone. Before we went through what regions and zones are, and now we need to understand why we need to consider these factors when we're choosing our regional zone. We have a cost variance between regions. What that means is resources that are more in demand in one region might cost more than those that are less in demand in that region. Or you might find the same resource cheaper in another region because it's not as in demand in that region as it is near you. Data locality regulations. Some local regulations don't allow for specific data to be stored, and you need to be aware of that before you purchase the storage space. High availability. Higher availability, so if you have customers in Europe and Asia, it's best to choose zones there instead of choosing zones that are in the region of the US. Latency due to distance, this is a similar concept. The further your customers are from your data center, the higher the latency will be. Hardware needs. Some machine types need specific hardware, so not all hardware is available in all Google Cloud data centers. Therefore, you need to choose the regions and zones where that hardware is present. This is a new concept that we haven't covered before, which are preemptible VMs. These are virtual machines which can shut down at any minute. They can shut down for sure after 24 hours. They're not always available, so don't depend on them. And data on them can't be migrated to normal VMs. So if you're planning to return anything, you'll definitely prefer to opt for a normal virtual machine. In that case, why would we use these preemptible VMs? Well, they're extremely useful for tasks that you don't need longer than 24 hours to run. Plus, they're really useful for tasks that can be run at any stage and you don't need it to run at a particular moment. If they shut down, they could just restart. We'll have a look at a couple of these scenarios later on. Now we're moving on to managed Kubernetes clusters. This diagram should look fairly familiar with one or two exceptions. Managed Kubernetes clusters have roughly the same infrastructure. They do sit on servers that sit on Google Cloud data centers. They have an operating system, but instead of a hypervisor, they use a container manager. In our case, Kubernetes. We discussed in the last video that Kubernetes is an orchestration platform. Therefore, it's a manager. It's a container manager. On top of that, instead of having virtual machines and having ourselves guest operating systems, we have a container, and on that we have our virtual machines. This is just good to know. Now, moving on, we're looking at serverless computing. In the previous video, we mentioned that we do have 3 types of serverless computing, but let's dive into it a little bit deeper. We have 3 types of serverless computing. We have cloud functions, which is good for event response, like uploading a file. We have 2 types of app engine. We have flexible app engine and standard app engine, but app engine in general is good for mobile and app backend. Flexible app engine is better for third-party softwares, so things like Docker, whereas the standard one is just a language-specific sandbox. Both app engines use Java, Go, Python, and Node.js. This information you will probably need in the exam. Let's move on to databases. Here I have a table that I drew up to show the general query language and details to help differentiate between database options. For example, if you have a question in the exam that requires a relational database, you can straight away see that the 2 databases that say relational are Cloud Spanner and Cloud SQL. That way you can narrow it down to 2 options. This is good to know, and this table is very, very useful for questions that ask you about data storage and databases in the exam. I would definitely recommend memorizing this. If you have a look at this, everything is NoSQL with the exception obviously of cache, which is memory store, and Cloud SQL, which uses MySQL and PostgreSQL. Next, we want to have a look at networking components. We've got VPCs, which we discussed before, but what we didn't say is that you don't actually need public internet to access these VPCs. Instead, you can use Google's global network, which makes it highly available and much faster to use these VPCs. VPCs can be linked to on-prem VPNs, and that makes it slightly less secure than we'd like it to be, which means that if you're using the internet, you're really going to need to secure your VPCs. So you can link it to an IP security, which is Internet Protocol Security, IPsec. The next point is load balancing, and this shouldn't be new to you. We've discussed this previously. Another concept that I wanted to discuss and that comes up often is Cloud Armor. This is a service which builds on HTTPS load balancing service. It protects against DDoS attacks. Now, DDoS stands for Distributed Denial of Service. So you want to protect anything that you have on your system, and the best way to do that is using Cloud Armor. Cloud CDN and Cloud Interconnect are briefly explained here. However, in the next couple of videos we will have to go into more depth because these are very, very important concepts. Please have a read of the description and note it down if you want to. Don't worry if you don't, we'll come back to these. IAM, which is Identity and Access Management, helps you to control and assign roles of users in the console. It's a key concept and we will have a video dedicated to this. For development tools, we've got IntelliJ, Maven, we've got PowerShell, Visual Studio, and a couple of others. That way, you're not really left without any options. And another core concept, as we mentioned at the start of this video, is stack driver management. We call it stack driver management because once you switch on stack driver, you can use all of these management tools. So if you look here on what you will see in the console is your operations, you've got your monitoring, debugger, error reporting, login, profiler, and trace. And stack driver is not listed here as an option because these will only switch on once you've switched on stack driver. As it says here, stack driver deals with the metrics, logs, and event data. Then you have monitoring, which is for your performance data. Login, which stores and analyzes alerts on logs. We've got error reporting, which is for your crash information. Trace, to identify performance lacking areas. Debugger, as it works for your normal code, it inspects execution of code. And then we've got a profiler for CPU and memory utilization details. These you can switch on and off and pay for as you need to in your team. Once again, we're coming across specialized services, and this is a diagram that we drew up in the previous video. We won't need to go into detail again for now, but we will in the future. So for now, I just wanted to go through the characteristics of why specialized services are so important. Specialized services are serverless. Again, if you remember from the last video, we said serverless doesn't mean there's no server behind them, it just means you don't have physical access to the server. Serverless means you have less configurations and you don't need to manage it, it's managed for you. Specialized services are really good for specific functions such as machine learning. They do exactly as they say, and they are there for a specific thing. You get an API to access its functionality, and you can get an external or an internal depending on what you need. We've got the pay as you go for what you use functionality again, which means that you don't overpay, but also that you are able to pay for anything that you have switched on and running, and then when you shut it down, it stays on the background. Pluses to using specialized services is having access to machine learning concepts such as AutoML, Cloud Natural Language Processing, Cloud Vision, and an extra bonus that we will discuss in the future is Cloud Inference APIs. Thanks for tuning in, hit like and subscribe, and let's go on to the next concept.